Greetings everyone, hope you are doing well. Myself Anvav Gupta. Today we will be solving Leetcode Biweekly Contest 54. We will be solving the first three questions. The last one would be solved in an entirely other video because I think so that's a tricky one. If you want me to solve that one, you might as well comment down below and I will make a video as soon as possible over that. Let's start with the questions. So the first one is that we are given a vector of ranges and two integers left and right, and we have and each range is represented with an array of two elements, start and end. We have to return true well if each integer between left to right is covered by at least one of the ranges, and otherwise false. So it's a fairly easy question. Like in this example, you can see left 2 is covered by the first range, 3 is covered by the second range, and 4 is covered by the second range, and 5 is covered by the last range. So we return true. Similarly, in the second one, we return false. Yeah, because 21 isn't there in any one of the ranges. So what I have simply done is I have uh, traversed through a loop from left to right, and for each integer I have checked through all of the ranges if that particular integer I is covered by any of one of the ranges. If not, then j would come out to be equal to the ranges dot size. That means ranges array would end, and if ranges array comes to an end, then I will return false because the ith integer wasn't covered by any one of the ranges. And at the end, if it's never returned false, then it means we need to return true. So let's run it, and let's submit it. So yeah, it's accepted. It was a fairly easy one. For the next question, there are n students in a class numbered from 0 to n minus 1. The teacher will give each student a problem starting with the student number 0, then the student number 1, and so on until the teacher reaches the student number n minus 1. After that, the teacher will restart the process starting with the student number 0 again. You are given a 0 indexed array, chalk, and an integer k. There are initially k pieces of chalk. When the student number I is given a problem to solve, they will use chalk I pieces of chalk to solve that problem. However, if the number of chalk pieces is strictly less than chalk at I, then the student number I will be asked to replace the chalk. Return the index of the student that will replace the chalk. So in the first example, as we can see, it's an array of 5 and 5, and the teacher starts with the student 0. Student 0 uses 5 chalk pieces, so the remaining chalk pieces are 17. Then student 1 uses 1 chalk piece, remaining pieces are 16. Student 2 chooses 5 chalk pieces, and the remaining pieces are now 11. Then again teacher starts with student 0 and he requires 5 chalk pieces, so the remaining are 6 chalk pieces. Then the student 1 requires 1 chalk piece, so the remaining chalk pieces are 5, and the student 2 uses 5 chalk pieces, so now there is no remaining chalk piece. So the teacher again comes to the 0th student, and the student 0 does not have enough chalk because it requires 5 pieces of chalk and we have 0 pieces of chalk, so they will have to replace it. Similarly in the second example, so in this one what we can simply do is I have taken the sum of all the elements, and because the teacher, until unless all the students are covered, like for suppose they would be covered certain number of times if k is much bigger than the sum, and so they are covered multiple times, all the students. And so what is the remaining chalk pieces with us? That would be obviously k modulus 5 modulus the sum of integers. So that is the value, and if p equals 0, that means at the when the teacher comes to the last student and the last student's need of chalk pieces is also satisfied, we are left out with 0 chalk pieces. And so I will return the 0th student will have to replace it, so I will return 0. After that, if p is not equal to 0, that means p is greater than 0. So I have simply traversed the loop once and checked, because right now the remaining chalk pieces would obviously be smaller than than the sum of all the elements. And what I will do is, for if my remainder p is greater than or equals to the number of chalk pieces required by the ith student, then I will deduct the number of chalk pieces required by the ith student from my remainder. Else I will return the ith student, because now the number of chalk pieces available is strictly lesser than the number of chalk pieces that the ith student requires. Then I will simply return I, and this is mainly the solution. Let's run it. And so yeah, it's giving 0 0. We shall check for the second example test case as well. So yeah, it's giving the correct answer. Let's try to submit it. Yeah, it's accepted. Let's move on to the third one. So basically a magic square is defined as a k cross k square matrix wherein the sum of all elements in the row, all elements in the column, in every column and in every row, and also the elements on also the sum of elements on the primary and the secondary diagonal are all equal. So in this one, as you can see, like 5 plus 5 plus 2, that is 12, 1 plus 4 plus 7, that is 12, and 6 plus 3 plus 3, that is 12. All rows are having the same sum, um, that is 12. And so, and for each column, the each column sum is 12, and similarly you can see 5 plus 1 plus 6 12, 5 plus 4 9 plus 3 12, and 2 plus 7 plus 3, that is also 12. So all the columns and all the rows are having the same sum, that is 12. 5 plus 4 plus 3, the sum of elements on the primary diagonal, and 6 plus 4 plus 2, that is also 12. And so the primary diagonal as well as the secondary diagonal are also having the same sum, and that too 12. Hence this particular square can be called as a magic square of dimension 3 cross 3. Then yeah, so what we are required to find, we have to find the largest magic square and we have to return its dimension. Yeah, so here we can see the largest magic square is having the dimension of 3. Similarly, in the second example, the largest magic square is having a dimension of 2. And yes, so what I have done here is basically the largest magic square can have a dimension which is maximum of which is having a maximum value which is minimum of n comma n. So n, which is the size of the matrix, which is the number of rows, and m is the number of columns. So yeah, and for each that particular value of s, we are traversing through the whole matrix and checking if the ending points of the square. So the ending point of a square of starting from ij cell and having a length of s, what would that be? So that would be I plus s minus 1 and j plus s minus 1. If they are within the bounds, then I'm checking that if it's a magic grid starting from ij and having a size of s. So that is checked by my isValid function. So what I am doing is I am first taking the sum of first row, and if the sum of this first row is equal to the sum of each row and also is equal to the sum of each column, and also this is the same sum value for the primary diagonal as well as the secondary diagonal. If that is the case, then yes, we can say that the square matrix starting from ith row, jth column of size S can be considered as an answer, and our answer variable would be updated with S, which is the size of the square submatrix. Now I am traversing through all the rows and calculating their sum. If that particular sum is not if that particular row sum is not equal to the sum of the first row, then I'll simply return false. Similarly, for all columns, what I am doing is I am checking if that particular column sum is equal to the value of sum calculated for the first row, and if that's not the case, I will simply return false. Similar is the case that I would be doing with the primary diagonal as well as the secondary diagonal. And if nothing of that scenario occurs, that means that all the rows, all the columns, and the primary diagonal as well as the secondary diagonal, all of them are having the same sum. Hence, I'll return true. And whenever I'll return true, my answer would be updated with the value of S. And at the end, I will simply return the answer. So it's fairly complicated algorithm in terms of time complexity, though it's quite simple in implementation. And let's try to run it. Yeah, it's correct. And let's submit it. So yeah, it's accepted, and all the three questions we have done right now. And the last question was a bit hard one, and I would surely be making a video if it's requested in the comment box. So I would request you all to please comment down if you want me to make a video of this question. Also, there's one question that I wanted to ask you guys, whether you want more such solutions in English, or I can also provide the same solutions in Hindi as well, or both. I will go along with the future videos with the decision that I feel majority is taking in the comment box. Till then, keep coding. Thank you so much.